Hi, I'm an old guy and I do maths, and today we're looking using a sine graph example, but this also works for cosine graphs. We're looking at how to get from measurements in radians across the x-axis to something like this, where we have integers. We have ordinary numbers across the x-axis. And the reason we're doing this is because sine and cosine graphs are often used to model recurring phenomena, such as tides or sound waves or something like that. And the example that we have down the bottom might be the modeling of tides with a 3-meter high tide and a mean of 0, and then 3-meter low tide. So the distance between high tide and low tide would be 6 meters. Right, let's get to work. So our standard sine graph looks like this. If we wanted to increase the amplitude, we would put a number here, greater than 1. If we wanted to decrease the amplitude, we would put a number smaller than 1 here. And the way in which we deal with the period is to multiply this x by something. And the calculation for a period involves this little formula. So what we're looking at is finding some value of n that will take us from radians to numbers such as 24. So let's get to work. Let's look at what we have to do to the equation of a graph such as this to get a result like this. Well, the first thing is, and the easy thing, is to take care of the amplitude. That's 3. That's going to increase this point from 1 all the way to 3, and take this point down to -3. Despite my poor drawing, that's meant to be -3 there. The really burning question is how we get these numbers along here. And I'm just going to use this space here to explain that. So essentially what we need to do is we need to take our formula here, 2 pi on n, and this is the formula for the period. Now the period of this thing is 24, so what we're going to do is we're going to solve n for 24. Nothing more than that, and I've probably got enough room here to do it. So 2 pi equals 24n. 2 pi on 24 equals n. N is going to equal 1 on 12 pi. So pi on 12, if you will. I hope you can see that, pi on 12. That was a bit cramped, and I apologize for that. So what we're going to do now is we're going to try that out. So if we rewrite this as y equals 3 sine pi on 12 x, what is the effect of that? What is the period of this? Well, the period is 2 pi on n, so we are really just reverse engineering this, but we'll go through the motions. So that's 2 pi on 12, which equals 2 pi on 1 times pi on times 12 on pi. Got carried away there, forgot to invert this. Those two cancel, so we get 2 times 12, which equals 24. That is how we get to having the number 24 here, 18 here, 12 here, 6 here, 0 there. That's how we get whole numbers along here. Okay, thank you very much for watching. I hope that was useful. There are a number of videos like this in the playlist. showing you various ways in which you can manipulate sine and cosine functions to give you a graph that's useful to you. So if you found this useful, please like and subscribe and have a look at the other videos. See you next time. Bye.